Good afternoon, good evening, good morning. I'm not sure where you are all located. I'm very honored to present on Operator Con about an operator with a well-known Java application server. My name is Michel Schildmeijer. I'm from the Netherlands. I live in Amsterdam. I'm a consultant and lead technologist at Qualogy. And Qualogy is a company which is located near The Hague in the province South Holland. And I wrote 2 books about WebLogic almost 10 years ago now. And my IT career started in 1994 with basic Unix and got along with all kinds of technologies and doing a lot of technologies the latest years, a few years around Java, WebLogic, and the last few years I'm focusing also on containerization and cloud and DevOps, all the buzzwords you may see pass by on every presentation you follow, or maybe you'll give it yourself. So I don't know all your background. Today I will tell something about an implementation of an operator, because that's what this conference is all about. Already told you I was very honored to present. Last presentation I did was at KubeCon in Shanghai in 2019, so it was real fun. Now it's all at home. It can be fun, but yeah, in person it's also always better. But well, we have to deal with the situation right now, so I try to make the best out of it. I don't see you, I don't see your reaction, so I don't see any surprise or any other faces, so I'll just keep on talking. And well, if you have any questions, you can ask them to me either through the well-known channels, socials, and maybe in the chat. So let's start. So the topics for today is that to make things clear, I want to talk about how WebLogic traditionally is built. Not too long, because that's not really interesting maybe for an operator's perspective. Then I want to talk a little bit about container transformation it has gone through, and also belonging to that, the operator, which is written specific for WebLogic as an application server. And in the end, some operational stuff around how to use the operator within such an environment, such a Java application server as WebLogic is. So first of all, WebLogic traditional. I don't know if you know the concept a bit about WebLogic Java application servers. You have a lot of others, of course. You have IBM WebSphere, you have Tomcat, you have Wildfly, OpenShift from, sorry, not OpenShift, the one from Red Hat. But WebLogic works with the concept of a domain. And a domain is in fact a configuration of all kinds of resources which has to be configured to make a domain run. And these resources can be anything. First of all, let me draw a schedule of how a domain looks like. You have the configuration entity, which is called the WebLogic domain. It's named. You name it by some name, maybe domain 1 or domain 2 or any other name you require for that. In the domain, you have some running instances, and these running instances are, in fact, Java processes, Java virtual machines running as a process on the operating system, doing all kinds of operational stuff around Java programs, and also doing some housekeeping with garbage collecting and all those kinds of stuff, defragmentation. So a JVM is in fact the unit where WebLogic runs in, and from a WebLogic perspective, it's called a server instance. So the server instance is in fact the JVM, and this is running on a host. This can be a bare metal host or a virtual machine. Next, then you have managed servers, and the admin server is, as the name it already tells you, it's an administration server which controls all the configuration and the start-stop lifecycle actions. And the managed servers are in fact physically they are pretty much the same. There are also processes, there are also JVMs, they're running on several hosts, and they host in fact the deployed applications, the EAR files, the jar files, the WAR files, which you have in a Java application server. EAR files are enterprise application archives, and all the others. These managed servers, you can cluster them software-wise. So WebLogic has a cluster mechanism where you can have a high available, scalable unit of server instances running. And all these server instances are guarded by a process which is called the node manager. The node manager detects if a managed server is running healthy, and if it's getting overloaded or any other thing, then the node manager can restart it. Or when a Java process is killed by maybe a reboot of a server, then the node manager will automatically restart the managed server. And because we are talking about operators, a lot of what WebLogic does, it's a transactional system, but a lot of the things are located on a file system, so that's stateful content, especially the domain repository. So the configuration repository of the domain is located on the file system. And the same holds for all the WebLogic binaries and libraries, so the installables which you need to run WebLogic, so the Java install and the WebLogic installs are located on the file system. So within the WebLogic domain itself, you can configure all kinds of resources, JDBC for databases, messaging, transactions, additional libraries, security within your domain. So this is in fact how a WebLogic domain, in a sense, in the basic, looks like. Now go on to WebLogic Containerized, because you might wonder why should a Java application get containerized if you can run a Spring Boot application within a container. Well, a lot of companies have invested in WebLogic software many years before it became Oracle, when it was BEA already, and they have a lot of Java applications. I know companies who have around 1,000 WebLogic server instances running. So it's useful to have some kind of a migration strategy for migrating your application landscape to a more segmented or more microservice style architecture. And also you can look at your infrastructure, how you deploy, build, operate it, and configure it. And containerizing a platform like WebLogic can be a help of it within that, to help you in the journey to more a container native and maybe a cloud native environment. So when you look at the components, when you have a WebLogic application server containerized, then first of all you have the basics from your server where the WebLogic is running, or multiple servers, the Linux kernel with the various components like C groups, namespaces, security, and on top of that you run some kind of layers for your Docker software. So container software can be Docker or any other OCI compatible container software like Containerd. So libvirt is then the Docker implementation. It's the Docker layer for using the Linux kernel as containers. And then when you look at WebLogic within a container, the components which are built up, you first have a base Linux image, usually Oracle Linux, but it can be also Red Hat. And it can be the most slim version of that, because you want to remain your containers to be as lightweighted as possible, so not have a container of about 10 gigs. So that's why also Oracle chose to build the containers in layered layers. So container images are built in a layered structure. So the next layer you have in your container image will be the image for the JDK, the Java development kit, to run the Java programs, and the WebLogic binaries for install the WebLogic executables, binaries, libraries, and everything. And on top of that, you have an image which consists of the basic WebLogic domain, so a template which you can use and configure it for your own purposes. And on top of that, you can build your ears and your wars and everything on a different layer again to deploy your applications using all kinds of deployment strategies in your container pipe of your deployment pipeline. And when you look at runtime, well, Docker or any other container runtime can use runc as a runtime for your containers. And if you look at container-wise, and you can see your admin server is running an image as a process on your Linux server as a container, as a Docker container, or any other technology you use for your containerized platform. And the same for the managed servers. There are also a container, and you can in between you can put in a Docker network layer, maybe if you, it should be because you want to communicate between the admin server and the managed servers, and you have maybe a cluster of somewhere. But with all this, you don't have any orchestration. They are just running. You can maybe use Docker Compose for that, but the de facto standard, of course, these days is Kubernetes to run that. So when you look at WebLogic from a Kubernetes perspective, then you can see here all the components again, but then with some extra layers and with some extra tools. So you have your Kubernetes cluster running on a node, or maybe several Kubernetes admin nodes for your high availability. And on the other nodes, you can deploy, you can do it by labeling. If you have a licensed node, for instance, then you can label your nodes to run certain paths to run on certain nodes for WebLogic, for instance. But in this, you have your Kubernetes cluster, and around that, you still have your WebLogic cluster. So the managed servers within still know from each other, and they are all aware and high available and session aware of all the applications which are running. And the same counts for the admin server. It knows all the configuration status and life cycles of all the components within the WebLogic cluster. Next, you have some extra tooling for managing your WebLogic domain. You can use the operator, and you can use Helm to install the operator. You can also do it by other ways, but the common way for Oracle to do it is to use Helm. And Oracle also has created possibilities to do monitoring with open source tooling like Prometheus and Grafana. And for service routing, Oracle implements Istio for service routing within your WebLogic cluster, and using an external load balancing with traffic or Voyager, or maybe the load balancer of your cloud provider if you run your Kubernetes cluster in a cloud environment and manage Kubernetes cluster maybe. And so managing can be done with kubectl or maybe the graphical interface, the dashboard. You can use it for managing your pods and your configuration specific for Kubernetes. So when you look at WebLogic and its support for Kubernetes, Oracle is certified to run all kinds of CNCF stuff. So WebLogic is also certified to run on any cloud or any Kubernetes cluster, managed cluster, but specific certification will be on the Oracle Cloud and also on the Azure Cloud. So the managed cloud services for Azure and for Oracle are specifically certified to run Oracle WebLogic Server. And WebLogic is also certified to use for Docker, but also for other tooling, Cryo, for instance, and also to manage, migrate, and deploy everything using an operator which is especially written for WebLogic, which will come to in my next few slides. This is WebLogic multi-cloud running on Azure. I won't do a deep dive in that. So WebLogic Kubernetes already told you. WebLogic is certified to run from version 12 from Linux if you use Oracle Linux 7, but also Red Hat 7, up to Kubernetes 18, Docker, standard de facto. It uses SWAML as a network fabric, and you can use all kinds of routings, services like Traffic, Apache, Nginx. And using the operator, you can use all kinds of possibilities to configure your resources and to do some scaling within WebLogic. Next, a good thing of using the operator is to make use of the WebLogic deploy tooling, and with this you can make a snapshot of your WebLogic domain on a traditional infrastructure, like running it on VMs or so. You can create an image snapshot, and with this snapshot, you can convert them all to YAML files and configuration files to migrate your existing domain to a Kubernetes-like environment. So that is really an awesome thing. So when you want to deploy an Oracle WebLogic domain to Kubernetes, you have, in fact, a few models. The most common ones are the on persistent volumes and in image. And the domain in image you should use when you do some development stuff or testing stuff. But when you're running in production, it's advisable to run it on persistent volumes, because you have shareable artifacts within your cluster, within your WebLogic cluster, which you want to persist on some disk. So already told you the container domain model on persistent volume to preserve state, like if you have configuration or especially from transactions using messaging, JMS for instance, then you want to preserve state if something goes wrong, if a pod gets evicted or it's terminated, then you still want to have all the state within it. And also log files, other domain artifacts, security, maybe Java security stuff, key stores and everything, you want to preserve them. This is the domain model and Docker images, and I already told you more for testing purposes or development. So the WebLogic Kubernetes operator is in fact the mechanism to manage and to operate and to configure your WebLogic domain within the Kubernetes cluster. So the Kubernetes operators, well, I think you're all experts in what an operator is. Yeah, to me, I started this journey around 2017 from more traditional way of working to all these new kinds of technologies, and every day I'm still surprised of all the new things which are coming up when I follow all the things on blogs and on presentations like this, and I'll find it very interesting and awesome. So maybe I'm repeating some stuff, but you have to forgive me for that. But this is my view of how I see it. So why operators, and a specific why operators for WebLogic? Well, when you look at Kubernetes itself, it's very good in managing its own configuration. The same if you have VMs, it knows about the operating system, and it knows about how many storage and how many networking and how many CPU it has, but it doesn't know anything about the application or the database which is running on it. So the operator is to be used for managing these complex structures of a database, specific knowledge which you have for a database or an application server, is to be done with an operator. And within this operator, you can build everything you know about your product. If you have, in my case, WebLogic, you know everything about it. You know the configuration, pain points. You know all the interface which is using. So you can use the operator to extract all these things out of it. So yeah, I already told you why WebLogic Kubernetes operator. It provides all kinds of APIs to communicate with the Kubernetes cluster, in fact, and to do some extra operational stuff. Not very deep level, so it's not really the administration tool because you're still using the WebLogic tooling with that, but you can do some basic stuff with it. Especially for automating things, it's very useful to have the operator for doing configuration changes, for instance. But you can use it for lifecycle management, stop-start things, provisioning some new stuff, for scaling in and scaling out, WebLogic clustering, and to provision some security. So the building blocks for WebLogic Kubernetes operator are, in fact, some of the components which I already mentioned, the log analytics, Logstash, and Kibana, for instance, for using all kinds of log file monitoring and analysis. And on top of that, you can use all kinds of container runtime interfaces like Docker or Cryo or any other. And on top of that, you can install your WebLogic and Coherence, which is in fact a data grid, maybe a bit similar to Hazelcast in the previous presentation. And the operator can manage all these components for that. So the WebLogic deployment, the WebLogic operator can create your domain within a few minutes, maybe 10 minutes or so, and it can be done. First step is to do the domain creation. Then it will create all the server instances and clusters. It will apply the configuration, and finally do your application deployment using all the generated YAML files. So you don't need to generate them yourself. You have some input files which you use with shell scripts, and all the input the WebLogic domain needs will be deployed with a job. The WebLogic operator is written in Java, so it's about in the previous presentation, I don't think it was percentage, but in the 4 percentages of operators which are written in Java. The operator is open source, so you can participate in the project on GitHub. Oracle has a project on GitHub on which they develop this operator on. It's written in Java, and it's also using some shell scripts for parameterizing stuff. And it uses Jython, and Jython is a Java implementation of Python, and it's used to access your WebLogic structure within. So WebLogic uses mbeans, and mbeans are in fact little configuration items within WebLogic to configure a resource. So this is all programmatically done. The WebLogic Kubernetes operator itself, it can be installed using Helm charts. You can download the you can download the image from the Oracle Container Registry or from Docker Hub. You can download the software from GitHub, and you can use Helm charts to install the operator in your Kubernetes cluster. So looking at such a process flow of installing the WebLogic Kubernetes operator and installing a domain, then first of all you have your input scripts. So you have some shell scripts, you have some template YAMLs which you're using, and in this template YAMLs you can specify all kinds of things about how many managed servers do I need. Do I want to use Istio? Do I want to use Elasticstack for logging and for logging analysis? Sorry, and do I want to use Prometheus Grafana for monitoring? And all kinds of WebLogic specifics you can specify in these input parameters, and then the config maps will be created to create domain resources for your WebLogic domain running in your Kubernetes cluster. So the install domain inputs will generate these YAML files. Then the operator takes care of pulling the WebLogic image and create a domain resource which is ready to be deployed to your Kubernetes cluster. Within these domain resources, you have a persistent volume configured, either on any kind of storage, can be NFS or your cloud storage or any other. Secrets for using a database or for secrets for your domain, and some specific WebLogic domain configuration. As already told, like how many managed servers you want. Do you want to scale them? Do you want a dynamic cluster? So a lot of configuration is embedded within that. And then the job is created, then an introspection of all these configurations are done, and when this introspection is done, the actual domain creation starts. So under the hood there will be a kubectl, apply anything, and then the resources will be created in the cluster, and then you have your result of your WebLogic cluster running on several nodes. Already told you, if you label your nodes to run specific WebLogic instances on it, then it's configured in your operator. And with this operator you can create all kinds of extra configurations, like WebLogic has an admin console, and WebLogic has also a T3 protocol which you can run and use for using scripting interfaces, like the WebLogic scripting interface itself, T3, where you can connect to and maybe use some kind of a CI/CD tool. So managing your WebLogic clusters using the operator, using the Elasticstack for collecting your WebLogic log files, and the operational stuff starts up. And the operational things are done through the REST API of WebLogic. And you can also use policies. WebLogic Diagnostic Framework is a set of policies where you can do monitoring on, but also create policies of how to scale or scale down or scale up your WebLogic domain. And combined with WebLogic operator and the monitoring you have, you can scale up, scale down in a more automated way than do it manually. So this is a bit of the command. It's very simple. You might have seen it from other stuff you've done. This is just creating a cluster and creating a secret for your WebLogic administration user. And then you can install the operator itself using an image from maybe your private repository if you have some specific stuff to put into, or pull it from any public registry. And then you have your WebLogic operator running in a namespace, separate namespace, or maybe the same, but I would advise it to do it in a separate one if you have multiple WebLogic domains running in different namespaces. So these are the tasks I already mentioned. So the access to the container registry, creating the persistency, namespaces, credentials, and the initial creation. Okay, we'll go through that So these are the inputs which are generated with a shell script, which Oracle provides with the input and output to the directory. And with that done, the operator is triggered to pick up create domain jobs and create a domain according to the configuration specifics I already mentioned. And then you have a WebLogic Kubernetes cluster running with a WebLogic domain admin server and 2 managed servers, all on their specific nodes. And you can also specify replicas if you want to do it high available in a Kubernetes way of thinking. You can create replicas, replica sets from your managed servers as well. Some of the operations which you can do with the operator, they're already told you, not very deep dive, but some basic things you can do with it. Already mentioned start stop, so you can do a rolling restart for a WebLogic domain for if you want to update something and you want to maintain availability, then you can do a rolling restart with the WebLogic operator. For diagnostics, already mentioned, monitoring and log collection and analytics. So the rolling restarts can be done by the operator, but you can also do it manually, both ways. Only a full restart you have to do it manually, so you can't use the operator for that. And the operator uses server start policies for that, and these are specified. You can use like a command like kubectl patch using a JSON format for that to specify which server start policy you want to use to stop, start, or restart your managed servers, admin server, or cluster. Another operational stuff thing is to change your running already applied configuration. So you can use config maps for that. So when you have a bunch of databases connecting to your WebLogic domain through a JDBC interface, and you want to change maybe a password or maybe a JDBC URL, then you can use config maps, and you can use specific templates and macros for overriding some kind of configuration you want to change. And so modular, so you can use it for specific domain things, or modular stuff like JDBC or JMS or diagnostics within your WebLogic diagnostic framework. So this is how the flow is. You have your current JDBC config running, and with Kubernetes you create a configuration map for your JDBC configuration using an N file, a text file with a versioning and saying which template to use. So these JDBC module templates are available by Oracle from GitHub, so you can use this format for changing some stuff within this configuration of your JDBC. So in this specific example, you have here a applied JDBC XML file, and you can change in here the database secret because you have another connection or another user which is running. So you can apply this specific secret which you already created in an earlier stage and apply it to your configuration. And when done, the operator will do this underwater, and your new JDBC configuration is applied. And the operator will also handle then necessary restarts of your resources. So that will be done all automatically. The only thing you need to do is to create this kinds of stuff. My last topic around WebLogic using Kubernetes operator is monitoring. Oracle also has put a lot of effort in using open source tooling also in order to get more into the open source community. Oracle, of course, has the name of it as a giant software company, which is very closed and has its own specific products, specific complicated products. But the last 2 years, when Oracle released Gen 2 cloud infrastructure, then there's a lot of improvement on the cloud native and container native area. So Oracle has a lot of effort done in also using all kinds of open source tooling and implement it in its own products. As I already told you, WebLogic still needs to be licensed and to be paid, but all the tools around it, like this operator, is all open source. So for open source and tooling around monitoring, Prometheus and Grafana is the standard tools which are being used for running monitoring. And so for WebLogic is in fact using it, it's feeding it with all kinds of metrics out of the MBean structure I already mentioned, and it will be used it will be triggered by using the REST interface, and configurations will be applied using YAML files and JSON configurations. So the installation is very simple. Just install it, or you even can make it more simpler by specifying it in your operator job to say, I want to use Prometheus and Grafana as monitoring. So then you don't need to install it separately, because then it will be installed by the operator automatically. To get all the metrics out of your WebLogic domain, you have to specify one thing you need to do is to install a small web application which can export all the metrics out of your MBeans. So you have to deploy this WAR file into your domain, and it will export all the JMX metrics to import to it into Prometheus and Grafana. And this is an example of a query, of a diagnostic query from a WebLogic diagnostic framework query, and this is just a web application where some kind of deployment state and some all kinds of metrics are configured to export to your Prometheus. And this is a streaming thing, so you don't need to initiate this every time again. It's just a streaming thing. If you already configured it, then it will be running all the time. So this is an overview of all the components which you need for running Prometheus, Grafana, and ElasticStack. So this is Prometheus to scrape all the metrics from the WebLogic servers using this WebLogic WAR file already mentioned before. So it will be collected by Prometheus. Well, this is the standard way of how Prometheus works. Then you need to configure a data source to make it visual in your web interface, but you also can set up an alert manager and use a webhooks to alert outside of your WebLogic domain and outside of your Grafana. And all can be stored in a database, and this is all be handled by this WebLogic operator itself as well. So you can see it's really moving towards like what it should be if it would be an open source product. So this is a bit of the schema which I already mentioned. You have the exporter, the WebLogic WAR file, which exports all the metrics to Prometheus, create a data source for Grafana, and visualize it to a dashboard, and make all kinds of alert notifications for your operations team or for your monitoring, anything. Great. Well, that's about it. for me, it's the end. I don't know if there are any questions. If not, then I hope you enjoy your rest of the session and the rest of the KubeCon, which is about to start, I think, or maybe already started. I don't know. So I hope you enjoyed it, and well, maybe see you next time somewhere. Goodbye.